Hello? Yes, I'm already here. Eh? Oh? Wrong location? It's okay. You stay there and I'll be on my way.
One day later.
But should I open it? Nah, I will open it right now.
Wait! Are you serious? You want to drink that milk?
Yeah? Why?
We have seen that milk since yesterday.
So?
We need to check it if it's still drinkable or not.
But how?
Never mind, let's watch this video.
Together!
Video?
Assalamualaikum warahmatullahi wabarakatuh to our lecturer and viewers. In this video, we will be presenting about volumetric analysis, which is one of the most important techniques in analytical chemistry. It is used to determine the concentration of an unknown solution by measuring volume of a standard solution required to react completely with it. This common method, known as titration, and is widely used in laboratories, industries, environmental monitoring, food analysis, and pharmaceutical tests. The accuracy of volumetric analysis depends on proper experimental techniques, including the correct use of apparatus such as burettes, pipettes, conical flasks, and suitable indicators. In this video, we will be discuss about the basic principle of volumetric analysis, the preparation of standard solution, types of titration, and calculation involved in determining unknown concentration. Understanding this method is very essential because volumetric analysis is frequently used in laboratory experiments and plays a crucial role in obtaining accurate and reliable analytical results. Without further ado, let's get started.
First, what is volumetric analysis? Volumetric analysis is a chemical analytical procedure based on the measurement of volumes of reaction in a solutions. It uses titration to determine the concentration of a solution by carefully measuring the volume of one solution needed to react with another. In this process, a measured volume of a standard solution, the titrant, is added from a burette to the solution of unknown concentration. When the two substances are present in an exact stoichiometric ratio, the reaction is said to have reached the equivalent point. Next, we move on to type of titration. Depending on the chemical nature of component involved, titration are classified into four main types. First, acid-base titration. Second, redox titration. Third, complexometric titration. Fourth, and lastly, precipitation titrations. Then, what is acid-base titration? An acid-base titration is an analytical method used to determine the concentration of an unknown acid or base. In practice, it involves adding a solution of known strength to one of unknown concentration until neutralization process occurs. While the underlying science is highly reliable, implement this technique in a professional setting requires an evaluation of its practical strength and weakness. When selecting acid-base volumetric analysis for quality control, its advantages must be weighed against its limitations. On the operational side, this method is highly valued because it is simple, fast, and requires standard laboratory glassware rather than complex and specialized electronic instruments. It is exceptionally cost-effective due to the low cost and high stability of basic reagents like sodium hydroxide. However, the method possesses distinct limitations. One of it is it relies heavily on visual endpoint because Meng is naturally an opaque and white emulsion. Identifying the precise moment of a faint pink color changes can be highly subjective and prone to human error. Despite this limitation, This analytical methodology serves as a cornerstone for industrial food safety. Titration of milk. Titration of milk is a laboratory procedure primarily used to measure the titratable acidity, which indicates the quality, freshness, and bacterial activity of the milk. By neutralizing the acid in milk with a standard alkaline solution, producers can be determined whether the milk is fresh or turning sour.
Now, let's move on to the methodology. But first, we need to know what are the apparatus and reagents for this experiment. For apparatus, we need 10 ml pipette, 50 ml burette, 100 ml conical flask, measuring cylinder, and a retort stand. For the reagents, we need 10 ml of milk, 10 ml distilled water, 0.1 normal or 0.1 molar sodium hydroxide, and phenolphthalein as indicator. By using a 10 ml pipette, we transfer 10 ml of the milk sample into a clean and dry conical flask. Using the same technique, we then pipette 10 ml of distilled water into the flask to dilute the milk sample. Next, we shake the flask carefully to mix the milk sample with the distilled water. We add a few drops of phenolphthalein indicator solution into the flask and shake well. To prepare for the titration, the burette filled with sodium hydroxide solution is clamped securely and the conical flask is placed beneath the burette. The initial burette reading is recorded. The titration begins by adding the sodium hydroxide solution dropwise while gently swirling the flask. And then, the end point is determined by the appearance of a faint, persistent pink color. Finally, we record the final burette reading. The experiment is repeated 2 more times to ensure the accurate result.
For the result data, we use 10 ml of milk for our analysis. To make the titration endpoint easier to observe, we diluted this with 10 ml of distilled water. We then titrated the sample against a standardized 0.1 molar sodium hydroxide solution using phenolphthalein as our indicator. To ensure accuracy, we performed 3 concordant trials. As you can see from our result table, our readings were consistent, giving us an average titration volume of 1.50 ml of sodium hydroxide. Now, to determine the acidity of the milk sample, we will use a stoichiometry method to calculate the weight over volume percentage. First, we calculate the moles of sodium hydroxide used in the titration. Next, we apply the stoichiometry of the reaction. Since lactic acid and sodium hydroxide react in a 1:1 molar ratio, we know that our 1.5 times 10 to the power of -4 moles of sodium hydroxide perfectly neutralizes 1.5 times 10 to the power of -4 moles of lactic acid. Now, we convert those moles into mass. Finally, to find the weight over volume percentage, we divided the mass by our initial 10 ml of milk sample and multiply by 100. To sum up, our result of 0.135% lactic acid falls perfectly within the standard range for fresh milk, which is typically between 0.14% to 0.18%.
In conclusion, volumetric analysis is a fundamental analytical technique used to determine the concentration of solution accurately through titration. Throughout this chapter, we have learned about standard solution, titration procedures, indicators, and calculation involved in quantitative analysis. We hope this video helps you a lot and gain you a new knowledge. So that's all from us. Thank you for watching. See you next time.